Start recording again. Okay, let's look at assignment number 4. The last time we were together, we did go over in depth the first, I think it's about 8 problems here through 612. Those were all pretty much rectilinear velocities and such, and working on, practicing conversions and stuff. So we still had the last 4 problems to do, which are really the problems that we did this evening. We did examples that are going to help you with these. So let's take a peek at these last problems, which start on page 162. The first one you're going to do is going to be 621. 621, we have a reciprocating saw here. We want to use the relative velocity method to graphically determine the linear velocity of the blade as the crank wheel rotates counterclockwise at 1500 RPMs. Okay. Now, what I don't want you to do is worry about this blade. Don't worry about a special interest point. At this point right here, this joint, just put a regular slider and you just want to know how far it's going back and forth. That's it. Not how far, how fast it's going back and forth. You don't need to worry about the blade out front here. So this is just simply going to be a connector from the center here, a connector here, and then the slider. Okay. All right. So keep it simple. Keep it simple. All of the dimensions you need are right here. This problem is just like the piston problem that we did up here, except it's just oriented different. That's it. It's a slider crank mechanism. Okay. But it's the same exact process. Same exact process. As is 623. 623, we have a shearing mechanism here. We want to use the relative velocity method to graphically determine the linear velocity of the blade. So the blade in this case, slider going up and down, okay, as this rotates clockwise at 100 RPMs, okay? Same problem as the last one. That's a slider crank, and then as our example was a slider crank, so exact same process. So all you want to do is find out what is the VC, okay? That's going vertical this time, okay? So 2 slider cranks. The next one you're going to do is going to be 28, okay? 28 is the sloshing bath again right here. But this time, if we go to the top of the next column, you are going to find the angular velocity of the water bath, just like we did in our example, the very last example we just did. As the crank goes clockwise this time, 75 RPMs. So if we look back over here, this time we're going clockwise at 75 RPMs. Otherwise, all the dimensions and everything else are the same. Okay, so you can use that original diagram and just copy and paste it into your new file, but then your rotations on the crank are in a different direction and number. Okay, but process exactly the same. Now, the last problem you're going to do is going to be this hand-operated shear that we see right here. Okay, so the blade is going up and down, and here is the hand, like a manual operating hand tool. Using the relative velocity method, graphically determine the angular velocity of the handle. So this is going to be the W2. You want to know what this is when the blade cuts through the material at a rate of 3 millimeters per second. So that means that the blade is going down at this time. Okay. So if this is going down at 3 millimeters per second, what is the angular velocity over here? Now, the problem says also determine the linear velocity of point X. You do not have to do that. I have that crossed off. And you will also notice in the problem statement that I have that noted here as well. Only solve for W2, not X. Okay? So the last 4 problems, the last 2 examples that we did, you have, I think, good stuff to go on. Now, any questions about assignment number 4? Okay, same things are going to be required. The last four here are going to be a combination of hand calculations that I can read, units, canceled, everything, neat, and screenshots of the CAD work that you do. Okay? All right. If there aren't any questions, I'm going to stop the recording. Do not go